Okay, so this is an infection simulator, and we're going to go through a couple different scenarios and analyze some things. So the first thing that we're going to output is it's going to be our default that we're going to compare everything to. So the red dots with the radius, that's an infected person. The blue dots are people that are susceptible. The gray X's are people that have deceased, and the darker gray dots are people who are immune. So this is with a mortality rate of 2%, I think. And just to show how some of these configurations work, I'm going to change the mortality rate to something really drastically different, just so we can see it in the output, and change it to 40%. So yeah, as you can already see, there's a lot more gray X's, and this output on the right shows the populations over time. So this thing on the bottom is deceased people, and as you can see, it's much larger than what we had in our default. Okay. Another interesting configuration that we can take a look at is the recovery period. So this is the period, or like the amount of time it takes for somebody to either pass away to die from the infection, or to recover. So I just made it a lot shorter than it was in our default. And yeah, as you could have guessed, the infection dies out rather quickly because it's killing its host too quick, and it doesn't have time to spread itself. So that's interesting. What was it at? Like 15, 20? Okay. Next, we're going to take a look at the importance of flattening the curve. So I'm going to have to uncomment some things. Okay, okay, so yeah. In this scenario, we have two mortality rates. One is at 2%, but once we reach a certain threshold and the amount of infected people is more than we can treat, then the mortality rate for those people jumps to 25%. So this is like if there's no room in the hospital and someone can't get treatment, the mortality rate is going to increase. Now let's see what happens in this scenario. So yeah, I don't know if you remember from the original default, but the amount of deceased people ended at like 63, and it's already up at like 200 by now. This shows how important it is to flatten the curve, that is, to decrease the amount of people that have the infection at a certain point in time. Because, like I said, if it's over a certain threshold and we can't treat everybody, then the mortality rate will increase. Okay, the last thing that I want to show is a quarantining technique. I have to move some things around. Okay. Okay, so So how this quarantining method works is at a certain point in someone's recovery time, so after they've contracted the virus, they have a 50-50 chance of being placed in quarantine. And when they're in quarantine, they still have the same probability of dying or recovering, but they won't be passing it on to other people. And in our output, the quarantine is the very center of the map. Let's see what happens when we quarantine, oh, and the quarantine percentage for this is 50%. So 50% of people that contract the disease about halfway through their recovery time are going to get put into quarantine. So yeah, there's our quarantine spot in the very middle. If somebody recovers from quarantine, they immediately return to wherever they came from. And as you can see, the people with the virus is very minimal, and deaths are way down from our default. So yeah, these are the different scenarios of my project. Thank you for watching.